All right. So for starters, let me show you what the current code looks like, and then I'll kind of talk through how some of this was accomplished. I've only solved a little piece of the problem. That way we can put some more logic in. So notice I've dropped a player in here. So just like we had in our rollerball, I made him a sphere. Okay. And I happen to tag him as player up here, but that's probably not really necessary. But I did tag him as player. And I went ahead and added a rigid body to this guy. And now I also have a player controller script. Okay. Now, you notice here that I have north exit, south exit, east exit, west exit showing up for my script here. So if I go over and show you the code for that, what do you expect to see in that script at the very least? What kind of variables? Yeah, so there's going to be public variables at the top, public fields inside of this player controller script that will be for my 4 game objects representing my exits. Okay, makes some sense? The idea is when the game first launches here, our player sitting there in the middle of the room, and we can choose which exit we want to move towards. So right now I just have it working for the northern exit. So if I press up, he starts going towards the northern exit, but notice he just bounced off the door. The door is also has a collider, right? He's not a rigid body, I don't believe, but he's a collider. Man, he threw me all the way back. So in any case, we have that part going. So I want to kind of bring you up to speed on what did this. And then we also want to talk about another design pattern today called the singleton, which we are going to use. All right, so let's go into the code for this guy. So here's my player controller. And as you predicted, I'm going to have some public variables at the top for my north, south, east, west exit. Okay. The reason I wanted to know about those things is because I want my player to be able to head towards one of those, be able to go towards the direction for one of those. So the easiest way to know where those exits are is to make the game objects available in here so I can take a peek at their transforms, specifically their position, their XYZ position. Okay. Just like we had before, I'm also going to give myself access to the rigid body for my player. Okay, this is the guy that we're going to be applying forces to. We want physics to work on our player, just like we did in the rollerball little game. And then I picked a movement speed here. I made it public so it's tunable outside of this over in the Unity editor. Okay. Now, what do I do in start? Remember, start's kind of like our constructor. I go ahead and set the rigid body equal to whatever the rigid body component is of the owner of this script. And this script is hanging on our player sphere. So the player sphere owns this script. Therefore, this dot get component will ask the player's game object for his rigid body component. And we're going to store that in this variable of type rigid body called RB here. Remember, start happens one time. All right. And then this is for our singleton. You'll see why I'm using this later. So this prints something out to the console so we can kind of prove to ourselves that some logic is happening behind the scenes. So maybe ignore that for the moment. Okay, this isn't anything you'll visually see on the screen. It's something that you have to go and look at the console to see the behind the scenes output. All right, so now inside of our update, we are going to be responding to some key presses. In our rollerball example, we use the built-in whatever thingamajiggy, which I don't know, I didn't think it really made life any easier. So in this one, we're just going to have some if statements. It accomplishes the job for us. So effectively here, I'm asking if during this current frame, remember update happens every single frame. If during this current frame, the up arrow is pressed down, then I want to do something. So we're asking a question. So if during this frame the up arrow has been pressed down, if it became pressed down during this this guy, we're going to add a force to our rigid body. What force? Well, we got to give it a direction first. So the direction is going to be the position of our north exit. So I grabbed that north exit that I drug into the script over on the Unity side. Remember, we had the public variables here, and on player, here's the script. I have the north, south, east, and west exits right here. So I have access to those game objects, which then allows me to ask that particular game object, where are you on the screen? Now remind me, what's a transform? So when we think about game objects, every game object has a transform. What is a transform? Go ahead. Yeah, so it's 3 different vector 3s. Where is it? How is it rotated? And how big is it? Okay, so specifically in this case, I care where it's located. So I'm asking the north exit for its transform, and specifically I want the position vector 3 of that transform. Where is it on the screen? Because what am I going to do? Why did I make my player have a rigid body? I'm going to shove the player, apply some force to that player towards that position. Make some sense? And that's why I needed to make it a rigid body, so that physics can act upon it. And then I chose the speed at which it's going to go, and I just kind of flipped around speeds until it kind of sort of felt right. I made it a public variable, so you can tune it outside of this, but around 40 float, 40.0 float seemed to move fast enough that it felt like my game was doing something, but seemed to move slow enough that I could control it. Let's just go with something like that. All right. Now ignore this left key arrow for right now. Well, I'll show you what it's doing for right now, but I just wanted to throw the code in there to kind of give you the tools that we're going to need to solve our next problem. If you remember last class, I mentioned that we're going to be designing our room as this is our blueprint for what every room looks like in our dungeon. And when we go to the north, and we go through this door, for example, the next room we go into is going to be the exact same looking room, but with the appropriate doors removed. Remember that from last time? Okay, we'll have to figure out how we're going to represent what each room is going to look like and how do we get that data. But for right now, we effectively have a scene that represents every room, and we can turn on or off exits in that room as needed. Okay. Which means that as my guy hits this northern exit, what I ultimately want to have happen is I want him to go into the next room. The next room is a new room. Now we can do this a couple different ways. We can actually load a new scene, which is a brand new room with its own starting point, whatever. We could also just reset the current scene. So he hits that door, then he just plops back to the middle of the screen, and we turn off or on the exits that need to be there. I'm going to go with the idea of loading a new scene. Okay, so we can think of scenes as kind of like screens in our game. Let's just deal with that for this example. So in order to do that, we need to bring in the namespace for the Unity engine scene management. So built into Unity, we have the ability to store a bunch of scenes. Up to this point, our games have only had one scene in them. This game, we still only have one scene in it. We just are going to go to it multiple times. Okay, you can think of it like a scene in a movie or something like that. All right. So by having the scene management, we can then ask the scene manager to load a scene named Dungeon Room. And if you remember, that's what we named our scene here, Dungeon Room. Now, tell me something. What is load scene? Just by looking at it here, we're seeing some code being used, not defined, we're seeing it being used. What can you tell me about load scene just by looking at it here? You already know that it loads a scene, but give me some more information about what I might find if I were to look at the definition. Go ahead. I'm not asking what it ultimately does. I'm asking you to look at this. Is this a field, a constructor, a method? Is it static? Is it non-static? All that stuff. Go ahead. Okay, static what? Static method. How do you know it's a method? Got some parameter crap stuff here, and it doesn't seem to match the name of a class that we know of. So, and it's also not following the new keyword. So it doesn't appear to be a constructor. Doesn't appear to be a field because it has parameters. So it's probably a method. Now, what made you think it's a static method? Okay. So you strongly suspect this is the name of a class, right? Why do you suspect that's the name of a class? You already said one reason. It's like you don't see anything being instantiated anywhere. Fine, but it's possible there could be some kind of global variable named scene manager that is an instance or whatever. But specifically, why do you strongly suspect that this guy is the name of a class? Go ahead. Well, this could still also be an instance of the class. Why do we strongly suspect that it is actually the name of a class? Just by naming conventions. What makes us suspect that? Okay, you can say it's not using camel case. A lot of times when we have methods, we use camel case, although in this case, you see load scene is not using camel case. Okay, but more importantly, typically class names start with an uppercase letter. Whereas variable names, we usually would have start with a lowercase letter. Go ahead.
I think in C# they don't camel case convention.
Well, yeah, I guess it's possible, but I mean, I think that the camel case thing is more of a common programming practice. Just when you create a variable, oftentimes you want variables to have a name that's meaningful. And a lot of times the way you do that is using camel case, where you start with a lowercase letter, and then for each kind of syllable or each next word, you use an uppercase letter, hence the humps on a camel. That's why it's called camel case. So I would think that would be more of a programming thing as opposed to a Java versus C# thing. But in general, I typically name methods and functions starting with a lowercase letter, where clearly they have not done that here with the load scene. All right, so a lot of this might be an educated guess here, but we can say that we pretty strongly suspect that scene manager is the name of a class because it starts with a capital letter. So it's probably not a variable name, okay? We didn't notice an instance defined anywhere here called scene manager. So at least from our perspective, this isn't a variable. It must be something else defined someplace else. We suspect it's the name of a class because it starts with an uppercase letter. We suspect that this guy is a method name. Why? Because it has parentheses after it, and we don't see the new keyword anywhere where we're actually using a constructor. Therefore, we strongly suspect that load scene must be a static method. Why? Because we're calling it with the name of the class it presumably was defined in. That makes sense? So we can just look at code like this, even though we've never seen it before, and make a pretty educated guess of the kind of animal we're dealing with if we were to go and actually look at the code for scene manager. Go ahead.
Right there. Wow.
Oh, yeah, there we go. If you hover over it, it gives you some cheating stuff. Yeah, do we have 5 overloads for that? So sure, that's kind of the fancy schmancy stuff they give you for an editor, an IDE, integrated development environment like Visual Studio. Okay, so that's just exercising the things we've learned from Java that we can apply right here to C# to kind of get an idea of what kind of thing we're dealing with here. But ultimately, what does this code do? It loads a scene named Dungeon Room. If you don't have a scene named Dungeon Room, it's probably not going to load anything. I'm guessing you'll get an error out in the console. It might not do anything if I, so for right now, if I run this, I don't remember if I actually hit the left arrow or not yet. So my guy can go there, but if I hit the left arrow, I'm in a brand new scene that just starts from scratch. My game didn't start over. I've just started a brand new scene at baseline. Make sense? Okay. So let's talk about singletons first. Just as we have this idea of MVC, well, remind me, what's MVC? Okay, what does it imply? So yeah, it stands for model view controller, but and it's a design pattern, right? Design patterns are proposed good solutions to common problems, something like that. Specifically, what is the solution that MVC suggests? I repeated myself in classes. I keep saying it over and over again, right? You go ahead. Yeah. Yeah, good idea to keep your data separated from your logic, separated from your interface, your view. Okay. Why do you think it's a good idea to do that? Because as applications get bigger and bigger and bigger and more complicated, you end up with spaghetti code, right? Very hard to manage stuff. You got 10,000 lines of code right next to each other, and it becomes very difficult to manage. All right. So if you keep them in separate places, it might still become hard to manage, but at least you're dealing with all of the logic stuff here and all of the data stuff over here and all of my interface stuff over here. So it's a good idea to keep them separate. But remember, MVC is an idea. It's not an implementation. So what we've learned in here is how Unity accomplishes its version of MVC. We've made things inside of our scripts public, which then exposes them to our Unity editor. And then we could also drag things into our Unity editor, which then makes those actual game objects accessible inside of code, like we're doing with our exits here. Okay, so if you're stop this guy real quick. So for like my player, I have made 4 public variables for game objects, and I drug my north, south, east, and west doors in there. So now I have access to those game objects over on the code side. Similarly, on the code side, I created a public float called movement speed that I now have access to in here, so I can tweak the movement speed if I'd like from the editor side. That's MVC in action, the Unity way. So MVC is all design patterns are ideas, not implementations. Okay. So the next design pattern we're going to look at here, let's get rid of this guy, is called the singleton design pattern. Okay. One thing you'll often find with design patterns, this doesn't wholly hold true, but design patterns often have funky names. In fact, for a long time, and actually it's probably still a thing, you've maybe heard this phrase before, publish or perish. So in academia, we're supposed to write papers and do research and things like that. Design patterns are very easy ways of doing publications, because you can just say, hey, I have a potentially good solution to a common problem. All you have to do is come up with a funky name for it, propose your solution, and the end of your paper could just say, yeah, this didn't work. Don't do this. You've moved the field forward. Okay. Don't make your peanut butter and jelly by staple gunning the bread to the wall and just throwing the peanut butter from across the room. Tons of fun, but I've determined it doesn't work. Great. Still ate it, but Okay, but be careful with those staples. All right, so design patterns are kind of a dime a dozen. So really what we're looking at here are some of the ones that have kind of floated to the top, right? These are ones that become industry standards. MVC is an industry standard. Singleton is an industry standard. Some other ones, there's a factory design pattern that's also kind of an industry standard, and a zillion other ones, but these are the ones that have been adopted universally. So what Singleton says is it's a good idea to keep data that needs to be shared by multiple, I'm just going to say entities, all in a single place, rather than individually passing info around. Now, this is somewhat in conflict with a common programming I don't know, rule of thumb. I probably mentioned it last semester. We're going to say in conflict with global variables are bad. Okay, so there's kind of an old saying in computer programming that global variables are bad. So don't use global variables. At the end of the day, though, we want to use the right tool for the job. And if a global variable is the right tool for the job, we can really even think about singletons as global variables. Okay, we're going to look at an example here in a minute. Sometimes, let's say we have 10 screens in our application, 10 different scenes. And all of those scenes need to know about the current user that's logged in. Let's think about it from like an iPhone or an Android app perspective. You know, you log into your bank, right? And as you're going from screen to screen to screen, and there at the top, it says, welcome, Mike, right? It's got my name there on the top. Now, do you think it makes more sense for it to store my name in one place and have every one of those screens to have easy access to it? Or should each screen kind of pass along that one piece of, let's call it insecure, information from screen to screen to screen to screen, having to kind of reorganize your suitcase every single time you leave a screen? Kind of seems like it would be more convenient, at least, to throw it in one place if it's something that's going to be commonly needed by multiple screens in your application. Somewhere in there, there might be a coin flip situation where like, hey, only 2 screens need to save it or have access to it. Maybe I just pass it to that other screen to keep that singleton thing as minimalistic as possible. Because you do run into an issue if you operate under this guise that well, it just works when I put it up in the singleton. All of a sudden, you get into this habit of putting 4 million variables up in the singleton, and now your singleton is unwieldy. Can't organize it. So what do? Oh, let's create multiple singletons. Okay, so I've sort of kind of, now you're starting to get into the real life example of like a hoarder, right? You got 30 different singletons with 200 variables in each one, and you haven't even named them very well, right? You have like an int A in the middle of a singleton. It's like, oh, what did I use that for? All right. So we always want to use the right tool for the job. I don't like the idea of just globally saying, pun intended, global variables are bad. Use global variables when it makes sense. Use singletons when they make sense. Okay. So that's the concept of a singleton. Good idea to keep things in one place that's accessible by the multiple entities that need access to it. All right. That makes some sense? All right. So what I've done here is I have created a script in here, and all these are just sitting in my scripts folder. I've created a script in here called master data. That's just what I've named the script. You can call it my singleton or whatever you want. Okay. Now, there's a couple of different schools of thought for singletons. I'm going to show you the way I do it, which I think obviously must be the better way. There is an argument that if you never use the singleton, my version is still taking up memory. But I'd also make the argument that from a performance perspective, my version of a singleton is always going to be faster because you don't have to ask for the instance of the singleton first before retrieving stuff. Just call it a coin flip and just all agree that mine's better. So, all right. So in any case, here's that master data thing. Anybody notice one change for this guy that is different from our other scripts? Okay, I got rid of a couple of methods. Go ahead. Yeah, it's not a mono behavior. When we create a new script in Unity, the default thing is it's one of these dudes, this mono behavior guy, right? Okay, and mono behavior, really the starting point is there's two functions already in there. It's got that start function, which we know that all mono behaviors call start first, and they call it one time. And then it has that update function that we know gets called once per frame. Okay, there's some other things that mono behaviors we've seen, like fixed update and stuff, but kind of your go-to move is all mono behaviors follow that pattern. They're part of, I'm probably going to get attached to a game object. And when I first spin up with that game object, it's going to call start. And then every single frame after that is going to potentially update itself. So up to this point, we've always had these mono behaviors. I created this script the same way we created any of our other scripts, but the very first thing I did is I took that line of code out and I just deleted my the start and the update. Nothing says you can't have a start and update function in there. Just they're not going to get called automatically if it's not a mono behavior. And mono behaviors are what makes it compatible with the Unity game engine. All right, so this is my, and actually for right now, you could even just remove all these things up here too. You don't need access to any of those things as we have it written right now. So there is my singleton. Incredibly complex. What have I done in here? I'm remembering a single piece of information, right? I'm remembering an integer called count. And I've made it public, so it's accessible outside of here. This is not going to make it exposed to the Unity editor, though, because mono behaviors are not something that Unity editor knows about, or non-mono behaviors are not things that Unity knows about. This guy inherits from object, just like a plain Jane Java object that we've been writing all along, right? Okay. Now, this guy is static. What does static mean? Well, how do you call static members of a class? What's the name of the class in which it was defined? Potential members of a class are constructors, methods, and fields. Constructors would never be static. That kind of sort of breaks. That's not where we use constructors. We use constructors in context with a new keyword when we're creating instances, but we can have static fields, which are just our variables, and we can have static methods. Okay. So by making this guy static, that means we can access it by saying master data dot count anywhere in our program. So this guy is a singleton. If I go into my player controller here, notice inside of start, the very first thing I did was I just printed out whatever master data dot count was. Let me show you how you can see that. So over here, I'm going to go ahead and just hit play. Now my initial player has just been born. He showed up. They spun up his player script or his player controller. The very first thing that happens is the start function of that player controller gets called. And if I click on console right here, we see that it shows a 0 right here. That's the count. I printed out the count. And if you remember from our singleton, I started count off at 0. All right. Now inside of player controller, game is still running. As of right now, I have this code here where if I randomly hit the left arrow for no logical reason, right now, I can only make my guy go towards the northern exit. But if I hit the left arrow, I'm showing how to load another scene, but I also, on my way out, I increment master day discount. All right. So I am talking to that global entity, that singleton that's up there. So right before I load load a new scene, which happens to be a duplicate of the current scene, I'm saying, hey, increment count. And then what happens when the new scene loads? New scene loads. We have a brand new duplicate of our player, right? Who has a player controller. And the very first thing that gets called inside the player controller is the start function, which is going to, among other things, print out the current value of count. So if this works, what we're going to see is the count is now 1. So games running here. I can press up to move there. Now I'm going to press left. I've loaded a new scene. Notice my count is now 1. Press left. Now it's 2, 3, 4, 5, 6, 7, 8, 9, blah, 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 blah. Make sense? So what does the singleton solve for us here? Why is a singleton, how is a singleton benefiting us here? What does it allow us to do? Knowing what you know up to this point and subtracting from that singleton. If I say singleton is not something you're allowed to use. How do we get information from the original scene to the second scene? How do we get information from the second scene to the third scene? Think about a normal video game. The very first screen comes up and says, you know, how many players? 1 player, 2 players, whatever. Then, you hit start. How does the next screen even know how many players you picked? You have to have some way of getting the information you collected on one screen and one scene to the rest of your game. And you need to have a way of passing that information off. Now, so let's say I didn't show you a singleton. How would you go about getting that information of count between 2 separate scenes? Any ideas on things you would try? But that's kind of a fun thing you can do with Unity, is you can kind of sit there and mess around with the tools, the constraints. It's, it's almost like playing with Legos, and say, okay, well, what if I try to do this? Will that allow me to accomplish what I'm trying to accomplish? Anything else you might try if you need yours, because the direction we're going here is my next scene needs to know what doors it should have, right? And probably also needs to know what door did I just come from. If I go up here and I hit the northern door here, the next scene should have me entering from the southern door. Well, that next scene needs to know which door I should be coming through, right? So this scene needs to let him know that so he can start rolling out of the right door instead of just poof, magically showing up in the middle of the screen. That's going to make it feel like we're walking through the map. But we're going to have to program that. So any ideas how we can make our game communicate, or what limitation we would have been stuck with if we didn't have a way of sharing stuff between scenes? Go ahead. Well, if yeah, I mean, if you were loading another scene, yeah, there's probably multiple versions of load scene, similar to let me just see real quick. Scene manager dot load scene. Yeah, there's 5 overloads of this. Oh, come on. You're not going to show me the 5 overloads? There's a load scene mode. Give me a moment. Unity scene manager, load scene. Let's go to scene manager here. Is it going to show me the alternatives? There might be versions of load scene that take more or less parameters. Yeah, here's parameters you can send along. Okay. So you can package, we didn't know about this until right now, but you could package some stuff with your scene as you're loading it if you didn't want to just put it in a global. Android has something similar. If you've ever done Android development before, we certainly could use singletons, but I mentioned a little bit ago, sometimes you might have a situation where it's effectively a coin flip. Do I use a singleton or I just pass information between, in Android, they're called activities. Well, activities in Android has something called put extras that allows you to kind of toss some extra things into something called an intent on your way as part of launching the next screen in your Android app. And then when you get to that next screen, you can, unpack the bags that came with that intent and get those 2 or 3 pieces of data you packaged with it, as opposed to throwing everything up in the global singleton. Okay, so you can do something similar here. So scenes have an ability to pass things between them, if that ends up making sense. But imagine I gave the example a few minutes ago about, if you have a mobile app and every single screen has to have your username in it. It would kind of get annoying of passing your name from scene to scene to scene to scene when it's the same piece of data, where it would be so much easier if you could just put it in one place and just access it whenever you needed it, right? You could even make it a private variable and then give yourself a public getter to get that piece of information. Nothing keeps me from, if I don't want to let people externally change my count, I can make this guy private and then have a public static int get count and have this guy return. Now, I would always say master.count. But since I am a static method inside of master data, I am already coming from something known as a static context. So I actually could just say return count here, and it knows I'm talking about this particular class's static variable, class variable, class field called count. But I always use the full class name. Makes me spell things wrong less often. Plus, it's a little bit quicker. You're not requiring it to resolve it. No, you wouldn't. Why can't you use this? See, I paid him to do this. I paid him to walk into this trap. Why can't I use this? Tell me about this. What's this keyword? What does it do?
How a method refers to itself.
Not a method. This is how an instance of an object refers to itself within itself. An instance. This is related to instances of objects. When I make things static, what am I avoiding? I'm avoiding instances, right? I'm saying, hey, I don't want there to be multiple copies of this dude. I want there to be one copy. So this keyword does not exist inside of here because we do not have an instance of master data from within a static context. If I'm in a static context inside of master data, an instance did not call this guy. Now I can have other things. I can say something like public int give value, something like that. And I can say return, 14 for no good reason. Now, this guy is not static. So inside of here, we are dealing with a non-static context, which means this guy would need to be called with an instance of master data. Well, since I didn't write a constructor, I would have to come someplace else and I would have to do something like master data MD is equal to new master data, like that. And let me just, first of all, why is this guy in error right now? Remember the change we just made over here? Yeah, that guy's private now. I cannot directly access him. If I want to get read-only access, I need to use my get count function. All right, and this is just a spelling error. All right, so now notice that I can create an instance of my class with a constructor that takes no parameters, even though I didn't write that constructor. I didn't write a constructor in here. So one is provided for me that does nothing other than help me create that instance so that I can call this. Here's the constructor that I didn't write that was magically given to me behind the scenes, following the new keyword, just like Java. And now that I have an instance of that guy, I can say md.get, what do I call it? Get value. Give. I said give value. I don't know why I said that, but that's how I spelled it. So let's just roll with that. So there we go. I got md.give value. And it just returns 14 for no good reason. Okay. It's a security through obscurity. Somebody's looking at my code like, what is this guy doing? All right. But the reason we've just done some of this weird stuff is now I have a class called master data that has both static and non-static stuff in it. You don't have to just pick one or the other. You should still do what makes the most sense, right? You want to use the right tool for the job. I would say that it's very common for a class to be filled with either all static or all non-static stuff. It's probably not that uncommon to have a class that is primarily filled with non-static stuff and then has some static fields at the top. Maybe like a math class or something like that, where you might want to have access to like pi and some of the constants, where you might want to just say math.pi to get that value, not access it through an instance, but maybe you want to store unique expressions, and creating instances of the math class might make sense, just as an example. All right, so there are situations of that, but I would say in general, the way I write singletons is everything in there is static. I better have a really good reason to have an instance method, because generally when I'm writing a singleton, I'm solving the problem of putting all my stuff that I need to share among multiple, in this case, scenes, all in one spot. Make sense? So I don't need multiple instances of this dude, but we can have them. But inside of this guy, this is a static context. Inside of here, we are in a non-static context. This keyword exists. So does super. This keyword does not exist. Either does super. And the reason for that is because of the single word, static. When I made that method static, I said, you are owned by this class, not instances of the class. Therefore, this does no longer make sense. This is how an instance of an object refers to itself from within itself. I don't get instances of this object. That makes some sense? Okay, we'll settle up with Venmo later, since, like I said, I paid them to ask the question, needed to have the example. All right, so I'm going to go ahead and get rid of my give value. I guess I've had worse misspellings this semester, I suppose.
Yeah.
Ay. Okay. So questions about singleton stuff. All right. So now going back to my previous question, just to kind of keep the juices flowing a little bit. Oh, and right now I have an error currently in here because I did not access when I updated count. Because count is now private, I no longer can directly manipulate it. Right? I made count private. I gave myself the ability to get the current value of count, but how do I change the value of count? Create a setter or create a function just called, increment or something like that adds one to it. All right. I'm just going to go back and do this and then this. And then we're all happy again. All right. I would say generally, if I'm doing singletons, I'm doing it like this. It's probably data that I'm okay manipulating both directions, but I might choose to have some of them be private and then have public getters only if there's a piece of information I want to make sure doesn't get changed or something like that. All right. Now, one other approach, and then I'll kind of give the homework assignment at the last second. One other approach that you might use is we might have said, hey, I'm not going to load new scenes. I'm going to do everything within the current scene. Okay. But now you might need to keep track of information between iterations of your fake scene. One thing you can kind of pull off with this is you can put like a empty game object somewhere on the screen and kind of treat that guy as like the overseer. He has no visual to him. He's just an empty game object. You can create an empty game object here and just throw him in some random place on the scene. You could attach scripts to that dude and then just give that guy, drag him into all the different game objects and need access to him, and then you can access his stuff. Make sense? So these are kind of like the games you can play with Unity, doing things the Unity way. All right. So I'm kind of giving you this guy as a starting point. I'll upload the code. So you know how to load a scene. You know how to respond to the up arrow. All right. So what I want you to do, I will stop calling the give value thing here. So for homework, update the code to allow movement only to the north, south, east, west from the center point. That is to say, if you are already heading to the north, you can't pivot to the west. For example, if I've already pressed the up arrow, my dude's on the way, and then I press the left arrow. Right now, if I had coded to respond to the left arrow or the right arrow, whatever, he will go at that angle down. I don't want to be able to do that. You need to come up with a logical way of once I get rolling in one direction, I'm not going to respond to the other directions. I've picked to go to the north. Next thing that's going to happen, I'm going to hit the north door. Well, once I hit it, you can go south. I don't want you to do that. But what I do want you to do when you hit an exit, you should load the next room scene with your player in the middle. So you don't need to position him at the right logical door. Like if you went through the north, you don't have to be coming in from the south. But I do want you to, like right now, my thing, but the ball rolls and I hit the north door and then kind of bounce back. I want it to be if you hit the door, that automatically puts you into the next room in the middle as a reset. That makes sense? So submit the GitHub link and the self-assessment. And I will put the link to my thing given that. So just for those of you who want to see it again, I'll go ahead and update my code. Let me just make sure I'm in a current running state. All right, I'm in a running state now. So I'll go ahead and upload my code to GitHub. Starting point for homework. Commit to main, that commits it locally, and then I'll push it to origin, that puts it up at GitHub. Questions, comments, concerns, bribes? All right, have fun at the hackathon. I encourage those of you who didn't sign up to grovel and come anyways. Should be a good experience, and this is one of our main internship folks. This homework was going to take like 10 minutes.
Could take 10 minutes.
You have all the stuff that you need.
So why would you want to